Most bugs don't come from code you don't understand. They come from code you think you understand. You read it once, it looks familiar, and your brain fills in the rest. You stop tracing execution and start trusting the story that code seems to tell. That feels efficient. It feels professional. But execution never agreed to that shortcut. Every time your thinking replaces tracing, you create a blind spot. And blind spots are exactly where bugs survive without being noticed. Literal execution is simple. One instruction runs, state changes. That change is committed. Mental execution is very different. Your brain jumps ahead. It groups steps together. It assumes outcomes before they happen. When developers mispredict behavior, it's usually not because they misunderstood syntax. It's because their mental execution skipped something the CPU preserved. That gap between literal execution and mental execution is where bugs hide. Your brain cheats in predictable ways. It skips steps that feel mechanical. Temporary variables, intermediate assignments. Those steps don't feel informative, so your brain discards them. Execution never does. When you skip a step mentally, you're no longer simulating the running program. You're simulating the program you expect to be running. Most of the time that works. When it doesn't, the bug feels confusing. Skip steps don't disappear. They become invisible. Invisible state is dangerous because nothing looks wrong. The code is clean. The logic reads fine. Only your understanding is broken. This is why these bugs are hard to debug later. You're trying to explain behavior that never matched your mental model in the first place. Execution preserved the state. Your brain threw it away. Refactoring before tracing makes this worse. You improve structure around an incorrect mental model. You make the code look cleaner and harder to reason about. Tracing first feels slow because it prevents shortcuts. Refactoring first feels productive because it hides them. The order matters. If you don't understand execution, improving structure just locks in misunderstanding. Sequential thinking doesn't come naturally with experience. Experience pushes you toward pattern recognition and shortcuts. That's useful, until correctness matters. Thinking sequentially means forcing yourself to stay local. One instruction, one state change. It's uncomfortable because it fights how your brain wants to work. That discomfort isn't inefficiency, it's discipline. The thing that needs to change is not your syntax knowledge. It's not your experience level. And it's not how clean your code looks. It's how you read code. If you read forward, assume outcomes, and skip steps, you'll eventually mispredict behavior, even in correct programs. The fix isn't cleverness, it's discipline. Reading code the way it actually executes is a habit, and like any habit, it has to be trained deliberately. That's the shift we're building here.